Last thing we did last time was this exercise, where we took all of these classes and we put them in groups. We found out the relationships between them and came up with a project design for these classes. And we found that we were again applying the strategy pattern because we had removed behavior or algorithms from the individual classes and made classes for those as well. All of the weapon behaviors were their own separate classes, so that adhered to the strategy pattern. So we'll quickly talk about kind of bringing this back a little bit more abstract again. Why do we care about learning design patterns in general? I've motivated this a little bit throughout the class, or at least tried to, but in this industry, you're going to be designing solutions for large-scale problems. And those large-scale problems are going to involve things like communicating with other developers. You can make this process easier if you have a shared vocabulary. Some way of saying, could we implement the strategy pattern with this? If someone were to say that to you before taking this class, you just have to say, can you explain what you mean? Whereas after you understand the strategy pattern, it's short, sweet, simple language that has a very complicated idea embedded behind it. When you're in the workforce like this, that kind of shared vocabulary will make the planning phase of these projects much simpler, easier. Everyone will know what you're talking about. Think about the entirety of the strategy pattern and describing that entire process without using the concept of the strategy pattern. How long would it take you to do that? How many words would it take you to do that, to be able to describe what you meant without using that term? That would be a lot of language, a lot of time involving some diagrams, maybe a lot of diagrams, and leaving open a lot of room for misinterpretation. Think about using design patterns as shorthands like you would if you're texting somebody. It allows you to be short, to the point. It doesn't waste your time. Then you can start designing at the pattern level rather than at the object level. Rather than thinking about just what classes do we need to represent this, you can start thinking about what design should we implement that allows for scalability, that allows for abstraction, extension. When I originally wrote this slide deck, I hadn't written the UML slide deck yet. So here's some fun language. We call this UML, where you draw some arrows. Luckily, I very last minute decided to do UML before any design patterns. So having a common visual language like UML also makes this easier to be able to draw out what you mean, to be able to say, these are the reasons why we want to implement the strategy pattern. Actually draw out the UML, kind of like we did in the last exercise. And then you can make an argument such as, this is extendable. We can add behaviors. We can add ducts as we need to be able to create and evolve this system. Here's a question that I envision people thinking. So, is there a way to automate this process? If we decide, hey, we want to implement the strategy pattern for this, can't we just do something like import java.designpattern.strategy and then say strategy.execute or strategy.apply or something to just do the strategy pattern for us? To motivate this, I want to ask a fun question. I want this to be a little bit fun. Thinking about the scanner class, guess how many lines the fully documented class is? I'm very curious what people's guesses are for this. No pressure at all to be remotely correct, but
That's some errors that maybe we're trying to remove the highest line. 1700 or something.
is that an official guess?
Yeah, I'll say 17.
All right, any others?
I'll say 1701 so I can. how are we going? Like, who's ever, like, if you go over, you're done, or? how are
We won't use prices right, just the closest either side of it.
I'm doing 2.5 grand. 2.5. 2.5.
2,500? Any other guesses? Well, we can actually go there. It's 2,660 lines, 2,500 is really close. So we can actually go there and take a look at what it looks like, because that would be fun. Where is my mouse? Eraser. So here is the entirety of the fully documented scanner class. All of the associated imports. Here's how long a good comment describing exactly what it does looks like. Here we finally get into the class. Here are all the fields. A character buffer, a buffer size, a position, an object called a matcher for finding delimiters, a pattern, delimiter pattern, has next pattern, has next result, and these are all just private fields. Here we have all of the work associated with what a scanner does. And it just keeps going. So something that's really easy for you to use in the way that you've been using it, the implementation for this needs a lot of documentation, a lot of code, a lot of effort and work went into this class. You can imagine designing a scanner from scratch. How are we actually going to parse an unknown tokenized stream of input? How are we going to get that stream of input? Where is it coming from? How are we going to make sure that it's always coming in the same object type, even if you point the scanner at a file or you point the scanner at the console? We'll go with that word. So what's nice is you can just import it and have access to all of it, which is kind of what you've done so far, right? You import some things, you solve a pretty basic problem so far in your education, but you haven't had the opportunity to produce something like a scanner that is that many moving pieces together. So that's going to have lots of developers. You're going to have to find intelligent ways to make the scanner scalable, because you're going to find additional ways that you want to manipulate the scanner to have additional features as new features in Java are invented, as new ways of programming language optimization comes to be. You may want to extend and change how your scanner is implemented. So if you use design patterns over something that is that large and that complicated, you will have a much easier time making modifications after the fact. Here's a question to think about. Is it even possible to encapsulate the strategy pattern in some kind of code that you could import and use?
That like some large language model, policy of training, probably the first, I don't know if that counts as. Like, input,
It turns out the answer is no. It's just more abstract than that. It's a kind of design, not instructions. They're abstract instructions, they're not concrete instructions, so we can't turn it into a sequence of steps that can be automated. How you apply the strategy pattern is going to vary between the different applications that you might want to apply it to. So because of that, this is not something that can be automated. It needs to be something that you learn so that you can implement it yourself. So we have the same principles, but the actual implementation of what that looks like in a particular project is going to vary. So it's important to understand why that's the case as well, just why we can't import it and use it. That would be nice. There are a lot of really complicated algorithms out there that we can just import and use without really understanding it. But design patterns always need to be understood because there is no implementation for it. So that kind of motivates design patterns and learning design patterns in general. Any questions before we tackle the next one? How do we feel about the strategy pattern? Do we feel okay about it? Do we feel like you understand the basic idea, the basic intellectual idea behind it? Obviously, there is still some work to do with regards to getting you some experience with it. That's what the labs will be for. But I think if there are any misunderstandings about strategy, we should tackle them now so that you don't get knee deep in code and then realize, I don't know what I'm doing. All right, on to the next one, unless someone says something. All right, decorator. This is one of my personal favorite ones. I find it to be very intuitive. All right, so some motivation for applying the pattern. My task to you is we're going to create an ordering system for a coffee shop. So we have some coffee shop. We want to write a process for a user to come up with an order that they then place so that we would see that order so that we could make it and come up with the associated cost of that drink. So functionality, we need some kind of description of the beverage. We need a way to access the beverage's description. We need to figure out how much a beverage is going to cost for each of a house blend, a dark roast, a decaf, and an espresso. Design a solution that is able to produce one of these 4 types of coffee. Start with any UML class diagrams, draw some relationship arrows. How would you do this?
Superclass, like an abstract superclass copy. To inheritance again.
Yeah. That seems to be the most intuitive way to start, right? You just have some inheritance. We have a super class for everything that's shared in common between these 4 drinks. And then anything that is not would be put in the subclasses. So where would the descriptions of the beverages be? Since each description would be different, we need to define that all drinks have a description. So you would define the concept of that in the superclass, but then you would instantiate what the actual text is going to be in the subclasses. We need some kind of toString or description print that accesses those. Where should those be?
The toString can be in the superclass.
Yes, because it's going to be the same logic. You're just going to call and print the associated description, which that process is going to be the same across each drink. So that would belong in one place in the superclass. How about the cost? Same thing as the description. Each drink is going to have a cost, but the actual cost value needs to be defined in the subclasses. So in the super class, we know we're going to have some double cost or amount of money, currency. We talked about this as a design, kind of as a code smell, where when we talked about primitive obsessions, we talked about it's easy to just store an amount of money as a double, but then you can get rounding errors, you can get other things that you might not want. So maybe we actually want a currency class of some kind. Let's take a look at a possible solution. This is basically what we came up with. So we're going to have a description calling get description. Each subclass implements cost. The description instance variable is set in each subclass. So exactly as we mentioned. The description is going to be a string that is part of the house blend, dark roast, decaf, and espresso classes. And then the get description is factored up into the superclass. Let's think now about some pros and cons of this solution. What do we think?
I mean, if you're gonna have. I guess this is more just if you're gonna have like a roast method, like a roast make method, it'd be different for every subclass.
Yeah, luckily this is just the ordering system. This doesn't actually make the coffee. But we do need to be able to come up with the cost. We do need to come up with the actual order. What, if you're thinking about ordering at a coffee shop, what don't we do here that we might need to be able to eventually account for?
Double soy, extra ice, non-fat.
Yep, any customization you could make to a drink. Think about if we wrote this initially, what would need to change or what assumptions are we making without being able to add things like customizations, double shot, use soy milk or low-fat, non-fat milk instead of whole milk, or add whipped cream, add chocolate, add ice.
Couldn't we just like set up an inheritance hierarchy to allow that to be extended in that way? Because that way, if there's only certain customizations that can affect certain things, then you can just implement that with with that.
Potentially. We're actually gonna figure out that that's almost what that's kind of what the decorator does in a very different way. I'll show you the issue with the inheritance, and it's that the number of classes that we need is gonna explode. It's gonna be a huge problem, but at least we're thinking about it as a potential solution, which is a very good place to be. So that's a big con, is if we want to add some functionality to this, then we have the cost down in the coffee, but it's the cost for the base coffee with no modifications. How do we add modifications to that? So let's talk about extendability. Client comes back and says, all right, now we can customize a drink order with steamed milk, chocolate of some kind, we'll call that a mocha, even if it's not technically a mocha drink, and or whipped cream, we'll just call that whip. How easy is it to do this? All right, so think about your original UML diagram and now think about how would that UML diagram change to be able to do this. Actually draw this out. You can do this in pairs if you'd like. But draw a UML diagram that tries to account for the different coffee types and the different condiment types. We'll call them condiments, but ways you could change the order. Options. There's your partner. Your partner is missing.
I don't know, after suggesting extra credit for being here too. Couldn't tell you.
Where is he? I thought he was gonna. Come on in the street.
Something changed between yesterday and today. Now he hates me.
My first one was-
I'm just gonna assume that until I'm proven otherwise.
He saw I was doing, I can't do.
No, it's done now.
Thank you for moving.
Yeah, yeah.
I really need
This is why you communicate with your class, right?
Yeah,
I want everyone in here to be successful.
because I have, it was gonna be very crunching, because I have to turn in an assignment Friday and tomorrow,
Mhm.
and then if we also have the lab on Friday.
Yeah. It's a lot of work.
Which is why I asked, like, you were earlier, like, how, what helps you focus, cause like. I really need one more, cause I need to focus a lot more, but I get. Like, it's just something, and then, just like some small thing, and it'll take my mind to like yesterday, like my room, I just heard from like the kitchen that my roommate was like making some noise, and I'm like, what is that? It's starting to bug me, what is it? And she was just scrambling. I don't know, it just like some small thing, and then I just get distracted.
Mhm. Being able to recognize that you are distracted. The very important part of that is not to beat yourself up. When you recognize, focus. You can, there's a difference between something that's productive, redirecting your attention, and something that is not productive, beating yourself up over being able to be, having the distractions happen. Recognize that it's a long-term process to learn to not be as easily distracted by something, and just find a way to catch yourself, all right? Redirect yourself to. Get back, all right, I see and hear the distraction, and I'm gonna choose to ignore it, to get back to what I'm doing, all right, where was I? Something like that, be kind to yourself.
Yeah,
Yes.
that might be a good first step.
Yes, that's something that I find a lot of college students struggle with, is when things get difficult, they tend to be hard on themselves. And college is about putting yourself in a lot of difficult situations and learning how to deal with that. The base step you can do is be kind to yourself. You're here, you're doing difficult things, you should be proud of just where you are at all times. Any ideas? What have we come up with so far?
A bunch of green fields.
Then how do you calculate the cost of a drink? You're gonna have this massive kind of switch case situation, aren't you?
Yeah.
Isn't that how a menu works, basically? You order number, get number two.
We've gotta come up with some better way than that. Some better way than having code that looks like a massive menu. Because if you think about it, there's a menu that tells you what the options are, but they don't give you every possible combination. It's not like something that says, if you'd like to order a mocha with 1 extra shot and whipped cream, here's what it will be. If you'd like to order a mocha with 2 extra shots and whipped cream, here's what the cost would be. If you'd like to order a mocha with 1 extra shot, no whipped cream, but soy milk instead of regular milk, here's what the cost would be. You don't have a menu that gives you all of those options.
Oh, I see, so instead of making a menu, we're making a build, like a building a drink.
Yeah, we want to be able to encapsulate the structure of being able to place an order without having to think about every possibility, every possible combination of ways to make the drink. So most solutions that I would think people come up with will not be able to scale because you're going to have to consider something like a class for each possible combination of drink. Or you have Boolean fields in every drink, and then you have to figure out, does this drink have this? Does this drink have this? Does this drink have this?
Just those simple additions, like, if drink, just like put in, steamed milk, steamed milk, chocolate, whipped cream, extra shot. Just add that all up, instead of have those be the variables and not the. Have those be the variables and then it all equates to the price of the drink.
What happens if you want to introduce a new condiment type? Let's say now we get almond milk in addition to soy milk. How many changes do we need to make to our code to account for that? We need to go change and add an else if block to every existing coffee type. So it's not particularly extendable in that We want to be able to independently add condiments without modifying the existing code, add drink types without modifying the existing code. You can see it's kind of the same problem we had last time when we talked about strategy, except that it's not really behavior anymore, so we can't as easily apply the strategy pattern to this. But the basic idea still needs to hold constant, and that we want to be able to make changes to our code and extend it without going back and modifying the work that we already did. It's a good idea. It's a great place to start. That's why this class exists, because these kinds of problems exist.
The pros are, it might work until you try to extend it.
It could still work.
Look, we're a small mom and pop shop, you know, we don't got all those fancy options.
What changes do you need to make if you want to do something like, all right, all coffee is 30% off today? What changes do you want to make if you want to, you can think that it's a very fragile system. You tweak the system just a little bit, you have a lot of changes to make to the system.
Maybe like a menu function, like an edit function, like before you add anything. Like you add it all in and then you give yourself the option to add unique item. That just, you can put in whatever value it is. Or to also give yourself the option of decreasing the values, like how much would you like to decrease the value at any point? And you say no, or say yes, decrease by 30%. Those are all good options.
You're assuming the client is both the coffee shop and the orderer now, which will be, if I give you, the customer, the option, do you want 30% off of your order, yes or no? Yes.
Is this from the perspective of the cashier or the customer?
The customer.
Okay, I was thinking of this from a cashier point of view.
That would make a lot of sense.
Yeah.
So let's take a look at a possible solution. All right. Oh, I did this out of order, didn't I? All right, pros and cons of this solution. Here's where we see the classes exploding. So we're going to come up with every possible combination of condiments. And there's going to be an associated cost to every possible combination of drink and condiment combination that are all going to inherit from beverage. So it's a direct lookup to the cost of that beverage. That would work until we need to introduce a new condiment, or the cost of one of your ingredients changes, so the cost of your drinks need to change. Then you have to go through and modify every single one of these that use milk. Even that's going to be a ridiculous thing to ask, because as more and more condiments become available, or more and more drink types become available, what happens to the number of classes that you need? It grows very quickly, doesn't it? You end up with way too many classes. So any change to the system causes hours worth of work of going and modifying this entire system to make sure that your online system stays online for very small changes. Small change, an entire day's worth of work for someone. That doesn't seem very cost efficient for a solution. So let's redesign this. This seems like a really bad idea. Let's collapse the inheritance hierarchy. And exactly as mentioned, we're going to keep track of each condiment as a Boolean field. So each drink either has that condiment or does not. We can write getters and setters for each condiment in the class. So we can figure out whether a particular beverage has chocolate, whether a particular beverage has whipping cream. Then you would write one cost function calculating the total cost based on the values of those fields. Subclasses would exist for each beverage type. The cost method of each one of those would set the cost as the base cost of the drink, and then the superclass would account for all of the condiments. So we start with the base decaf cost and then add the caramel, the whipped cream, the everything on top of that.
So basically, do a setter and getter that will go into these different subclasses, and then from those subclasses, then we have the options of that, like extra shot can, and all
Yeah, so basically that, the subclass is gonna tell us the base cost of the drink.
Oh.
What is the cheapest you could possibly order it with all of the condiments stripped away? And then there's a Boolean field with getters and setters for each one of those values. So you could figure out, does this drink have each of the associated things? So I talked a little bit about this. This creates a lot of if cases to figure out the actual cost of a drink. We have to go through every possible condiment and say, does this drink have that? If so, add the cost of that. If it does it have the cost of this, et cetera, et cetera?
Your setters could change the price.
Yeah, well, it would set whether or not the beverage that you're building has that. You'd be able to set it and say true or false, and then the cost would change appropriately. You can imagine this on on a touch screen where the method, the setter would be called when you press the button that says, yes, I'd like caramel on this. When you tap that button, the setter would be called to toggle the Boolean so that, you'd have some visual display that says, yes, now it contains it, and then you tap it again, no. And then the cost would be updating in real time as you increase or decrease the cost associated with setting that. The cost would change whenever that setter is called.
So the program can be like, open it up, it has a menu of the base ones, you say, I'd like a frappe. It's like, we could like extra shot, no, we like caramel, no, and then you just go down the options.
Yep. Questions about how that is set up? So now we look at something like this. So the beverage has all of its Boolean fields. We still have a description. And now we have like has milk, has soy, has chocolate, has whip. And then we can determine, has yes or no, does it have it, and set it, which toggles the Boolean on or off. So set milk would change milk from false to true. Set milk again would change milk from true to false. So you can imagine a touch screen that just calls these functions as you interact with it. And then as subclasses, we have the base costs. And then this cost would go through and figure out what does it have and tally the cost.
What if I want half normal milk and half soy milk?
Add a new Boolean, has half milk, half soy.
Yeah, like you want it half and half?
And then you add another one for 1/4 and 3/4, another one for 3/4 and 1/4, another one for 1/8 and 7/8. We can see some of the issues of how this explodes.
Dang, I don't wanna be a barista anymore.
I think you just wanna not code for a coffee shop. That seems like, it just seems like this is already too complex. Stop it, make this easier. Luckily, there will be something that will make this easier. There are still some problems with this, and we'll talk about exactly what decorator is tomorrow, since we are out of time. But thank you all for your feedback on the schedule. I will try to keep this as stress-free as possible while still meeting the outcomes, so that you're not throwing your money at me at the school and not getting what you're paying for. So, thank you for the feedback. See you all tomorrow.
Yeah,